multiply these things. It's basically the problem will give you, and the way that the book does stuff is that they will give you horizontal math. Don't ever write horizontal math. Always write vertical math. Here's why I mean by that. Because when you start, you're going to be adding these two things together or subtracting two things together. The easiest thing to do is to line up and make sure everything is in a descending order. And then you write down your first part. Then when you get to the second portion, you match up where everything goes, putting placeholders in for the missing. Because then you have vertical math. Vertical math is far and away easier for students to visualize and see than horizontal math, especially for adding and subtracting. Multiplying, because we do a lot of distributive property and all that doesn't really matter a whole lot. But when we set up these things for adding and subtracting, this has always been my suggestion, whether it's an Algebra 1 class, Algebra 2, whatever. Also, I usually do this. Oh, this is supposed to be cute. Oh, thank you. By doing that, it separates. I'm sorry, I don't mean to offend you. Sorry, man. I need to disappoint. Is that an orange Slurpee? Interesting. So, solid. So now you basically wind up here with 4 addition problems. What's 3 plus 1? We're adding between all of these. We have 4x cubed. 2 plus negative 10. Negative 1 plus 0. And negative 7 and 8. What I'm suggesting that you guys do when you do this is just to, when you read the problem out of anything, just automatically put the first part down and write the second one below it and just line it up. That way you're combining like terms. This is not a difficult. I know that we have all done this before. Right? Don't shake your head, no. Oh, man, it's smacking. Well, we have to do subtraction. Oh, yeah, smacky macky. It rhymes.
I'm sorry. Oh my god. Her name was Smacky.
Way to go, Smacky.
That's great.
Nicely done. Subtraction. What changes? Yeah.
I don't know.
I know. I'm like I said, I'm asking a lot today because it was cold out. So it's tough. So write out the horizontal, but when you put it together, you just make sure you. Oh, I know. When you do this stuff, space out the numbers between each other a little bit because it becomes a little bit easier when you draw it out for the 3 separate problems. Because what I'm doing here is that way I have space to say that it's positive 1 minus a negative 6, negative 7 minus a negative 1, 5 minus 3. I spaced it out that way. I'm just able to break it into those 3 parts. It's not a necessity that you do that. It's just a suggestion that you do that because, I don't know, I may or may not have taught this once or twice, and I kind of know where people tend to make stupid mistakes. So, all right, bear with me. 5 minus 3. All right, good job. It's 2. 1 minus negative 6. Negative 7 minus negative 1. Whew. Good work, guys. That was tough. All right. Good work. I am nothing but trying my best to help you do your best.
That sounds like something encouraging.
You're welcome.
But it's something encouraging. That's what that say, encouraging things, remember?
Oh yeah, that's supposed to be nice to you. It was pretty wall. What's that? Hey, do this one, not this one. Try one. I know this is tough. Good luck. Ah, yes. Murphy's going to start doing things like that more often.
What, maybe I'll turn in the homework?
Yeah.
Like you're supposed
No, you don't have to.
to. Sorry, like, teachers usually do. I don't mean to offend.
No, that's okay.
Forgive me.
Now, here's the thing. Up top here, when you wrote that out, you got to put a placeholder for 0x. So you have all your subtractions. Sorry, it's just looking bad. I just didn't rewrite, so screw you all. At least I did my homework.
Did you know?
Yeah, I went through and made sure I knew what I wanted to do today. Did my homework.
That's your homework?
Oh, we're going through all this stuff. What do you have
You
to
can
do?
co-sign yourself your homework, so you can go easy on yourself.
0 plus x squared plus x minus 8. Is that what you got?
Yeah.
That's fine. Yeah, is it wrong if you put a plus 0x cubed? You're just wasting lead.
I was doing this for like,
No, that's.
I'm old enough to have used a lead pencil, so it's okay.
that's
It's lead. I know, I still have a piece of it in my hand. Should be.
I don't think it's crap.
We're
twins.
I think those guys do that just around. No hair.
Oh no! We have to multiply now! It's a lot. I know, I'm asking a lot here. So here's where things start to get a little messy. Almost. When things start to get messy here, obviously what we're looking at here is distributive property times 2. And when I didn't mean to make that joke by times 2. What tends to happen here is that you will screw up a sign, you will forget to distribute to one part. It's just the silly stuff. It's not that you've never done this before. I know each and every one of you have. It's just a matter of making sure that you send the x to all 3 parts. You send the -3 to all 3 parts. And that's what you just have to get in touch with. It just takes a second to do it. Okay? So let's see, 3x cubed, 2x squared, minus 4x minus 9x squared plus 6x plus 12. And then what do you think you do at the end? Yeah, combine like your terms again and simplify out. Whenever I simplify long strings of polynomials, normally what I'll do, I always put them in, well, first of all, I always put them in descending order. That's the proper way of doing this. So I'll start with my highest degree, which was 3. So I have a 3x, excuse me, 3x squared. And I cross it off, that way I don't have to go back to it. And then I look for my squares. I have a -2x and a -9x, which gives me a -11x squared. Cross them off my list. That way I'm not double counting something, or that way I don't forget something. And then -4x plus 6 gives me a 2x and a 12. That way by doing it that way, it's nothing more than a visual check on yourself to make sure that you don't skip something. That's the only reason why I do that. I mean, you don't have to. There's no rhyme or reason. It's just because I'm weird and I do things differently, which I'm sure by first week of November you've kind of figured that much out. Smidge. All right. Oh no! Yeah, and that's the thing. I was looking at one like this. When you multiply out terms, one of the things that I wanted to show you with this is because later on, in about a week or so, what we're going to look at is we're going to take, we're going to write the polynomial with the given zeros. So if I want to write the polynomial with the given zeros, let's say my zeros are at 2, -3, and 7. If I have zeros at 2, -3, and 7, what would my terms be? What term gives me a 0 at 2? X minus 2. What term gives me a 0 at -3? And then at 7. So in order to write the polynomial out, then I'd have to FOIL all that out, wouldn't I? So basically what this is practice to get to this in about a week or so. That's why we do this now with the multiplying and combining by terms. Because eventually, not only will we do this, we're going to say write the terms with write the polynomial given those following zeros. You still do the same process, but you have to understand how you get to it. Okay? This is just a practice of combining by terms. So does it matter which two you start out with? Not at all. Normally when I have 3 polynomials written out, or 3 terms written out, usually what I do is I multiply the second 2 together, and then I have this one up front, so that way I can just distribute. Does that make sense?
Yes.
So then if I do this, then I have x squared minus 7x plus 10, and then I just distribute the x and the -4. It's just a suggestion. That's just how I've always done that, because I know that distributing from left to right is more normal than distributing from right to left. Remember, it doesn't matter the order in which you multiply, so either way is perfectly fine. What I'm getting at is that if you jump to a spot that's a little bit easier, it's a little less taxing on the brain, shall we say. Your pocketbook would not love taxes sometimes either. Checkbook, pocketbook, your billfold. Try to see your check register. So let's see, distributing out. Hey Abdullah, what was your PIN number again? Yeah, what's the 3 digits of the last credit card?
1, 2, 3, 4.
Ah, yeah.
It's like that 1
That way you can transfer funds so you can feed the poor. It's over here somewhere. This is Saskatchewan, yeah? There's never a dull moment around 8 o'clock in the morning, I think. Yeah. And there we go. Not terrible?
Not
So let's talk about this stuff real quick. Oh, how do I want to do this? Let me do this. Now, yeah, and I want to think about. I want you guys to start thinking about some of these shortcuts that are available, especially when you have scenarios that occur like this. Now, we've seen this when we went the other way. Is x squared a perfect square? Is 4 a perfect square? Is that a subtraction symbol? That means it's a difference of squares. The difference of squares means that you have the same terms, opposite sides. So we've done this problem going this way. What they're trying for you to see is that, oh, that's the same thing, so that means this has to be first term squared, last term squared, with subtraction in between. Because if you FOILed it out, you get plus 2x minus 2x. Is it wrong if you FOIL it out? No, it's not wrong. It's just time. And the thing is that if you understand and you catch it, you catch some of these quicker, it just makes your life a little bit easier. In the grand scheme of things, is it the end of the world? No, it really isn't. For any of these special patterns. It's just that if you catch it, it's a little bit quicker. Same thing goes for this. I don't know if we actually walked there or did this one completely. That's junk squared, isn't it? That's junk times junk. Now this is technically that. Now our answer is not x squared plus 9, because that's where you kill a puppy. Rip Fido, right? R.I.P. Fido. Now if you FOIL this out, remember what happens. You get x squared, 3x, 3x, and a 9. What's 3 plus 3? The special pattern that's happening is that if you take the first term, square it. Last term, square it. Since it's a plus sign in both of them, and then all you do in the middle, it's going to be 2 times the 2 other parts. It always happens that way. Because if you honestly FOILed that out, you'd wind up with 2 3x's. 3x plus 3x is 6x. If it was 4, 4x and 4x is 8x. If it was 12, 12x and 12x is 24x. It doesn't change that. Because no matter what, as you FOIL that through, this special pattern occurs. Again, if you see this where you have x squared minus 6x, I'm sorry, plus 6x plus 9. What's 9 you add together to get 6? 3 and 3. X plus 3, x plus 3. Close the computers, guys. I'm doing stuff. It's not a big deal if you have to FOIL it out. It's just pattern recognition sometimes it's nice to see. Right? The one that's going to be new, though, that you have not seen, is the cubes. The cube of the sums of cubes and the differences of cubes. Same thing, guys, same thing happens here when you have subtraction. Let me show you an example. Let's say we have 2x minus 3, and I have the quantity cubed. And I'm going to use the special pattern to write this out as opposed to foiling it out twice. What's playing the role of A in this case? 2x. Thank you for saying 2x. And B is playing the role of 3. Now, most people will not recognize that the A value is being played by the 2x because that's the entire first part of the problem. So the 2x is the A term. So as you go through that, that means you get the quantity 2x cubed minus 3 2x quantity squared times, what was the B value? 3 plus 3 2x 3 squared minus 3 cubed. Okay. What I'm doing there is I'm starting with my A value. My A value is the cube. The second time I use the A value, it's squared. The third time I use the A value, it's the first degree. And I don't use it the fourth time. The B value, I don't use it the first one. I have a singular value, squared value, and the cubic value at the tail. And then it's just 1, 3, and 3. When you have subtractions with this, it starts positive, negative, positive, negative. They alternate through. When it's a positive jump cube, they're all positive. So now, what's the quantity? What's 2 cubed? 8. What's x cubed? This one becomes 4 times 9, so I get 9 is 36x squared. The next one is 27 times 2, which is 54. And then minus a 27. Remember, all I'm doing there is I'm taking like 3 times 2, 6. 6 times 9 is 54, or 3 squared is 9. 9 times 3 is 27 times 2 is 54. You did a lot of math. What are we doing? No, you would. I don't know. No. Hey, is there a quiz tomorrow?
Okay.
Do that one. I love being big. It's fun. Neat. Just to school. Take Mackey's.
If you cover up the name, it's fine.
I'm trading for.
Just cover up the person's name, and then they walk up with the right name. Hey, I got it.
What are you going to screw up with this one? The negatives. You're going to screw up the negatives. Okay, you'll screw with negatives.
I don't know where I am. What did I get here?
What's 3 times 3?
9
Times 3.
27.
Would it be positive or negative? What's a negative times a negative? Times a negative. Now, what we're going to get at tomorrow is a lot of times one of the strategies for factoring is the fact that using grouping. Grouping works great when you have when you have 4 terms. You've done that before. You've done the grouping method when you had a 2x squared plus 5x or whatever, where you broke the split middle term, we used to call it, and you go for a trinomial to the 4 terms, and you group out GCFs. It's the exact same thing. If you were given this and you had to factor it, you group the first 2, and you group the second 2. What's the GCF between a negative 27x cubed and a 27x squared? Would it be wrong if I took the negative out? Nope. So if I take out the negative 27x squared, what am I left with? X minus. Did I screw something up in there? Yeah, because then if I should have been able to take out, this should have been the same. Did I miss that? I didn't mess up that pattern, did I? Minus plus. Minus plus. Oh, I didn't do a minus here. Sorry, this should have been a minus. Sorry, guys, that's why. Anyway, yeah, it should have been a minus. It should have been, bless you, plus minus. Yeah. But what happens then is you'll be able to pull GCFs out. I screwed something up there. Yeah. Plus. It's minus plus minus. There it was. Okay. Sorry. Thank you. It was minus plus minus. I'm checking. Minus plus minus. So we had negative 27. It was that then, right? Well, this is still the A value, so you still just keep the negative with it. Oh, but these were all plus. What am I doing? Oh, Murphy. Why am I Murphy?
I'm so lost now. 27.
Sorry about that. There you go. Wow, why did I screw that up so badly? Why can't I read it? I'm sorry. Why did I doubt myself? Alright, let me give you a couple of these to look at.
I demand to pay on my homework.
I
I can get strawberry. I want to do it without something gravy. It's not the same. Blueberry, banana, no, I can make like rice.
There, I made sure you landed on the right number. It's 12. It's just 12. Okay? Add, subtract, multiply. All right. I don't think I have the PDF loaded up there right now. I'll make sure I get that up third hour. So you guys